So as we start discussing quadratic inequalities, like I said earlier, it's a combination between two things that we've done before. Graphing parabolas and dealing a little bit with interval notation. So, a couple things up at the top we want to have a grip on, though, before we get too far with this. Okay. When I draw my parabola, should my function's boundary, and that's just a fancy word for, should my parabola be solid or dashed? Because that's actually going to let me know if it's or equal to or if it's not. So if I have an or equal to, whether it's greater than or less than, that's going to be a solid parabola, just like you normally would see. If I have a less than or a greater than, that will be dashed or dotted, if that's a better word for you. So once I get ready to graph my parabola, I got to look at that. Okay, how do I graph the parabola? Okay, I'm going to have options, and we're going to talk about these on each of the problems. I could use the calculator for quite a few things. I may need to deal with things in vertex form, where I use negative b over 2a to get the x value. Okay, that might be simpler sometimes. And my last option would be to find intercepts. Now, we've done all three of these. The question's going to be what's the easiest way on each one to be able to get where I'm trying to get to. And then finally, and we'll talk about number 3 after we've actually graphed our first one here on where do we shade. We're going to do a little shading on this because it's an inequality and we don't just get one answer. So here's how we're going to do this. These first 3 that I've got here are all in standard form. Okay? In other words, for these 3 guys, I'm always starting at 0, 0 for my vertex, but then I need to look around for shifts. Okay? So if it's just x squared and a number, this is how we're going to tackle it. Okay? Y is less than or equal to x squared. Now, there's no shifts. Okay? So I'd start at 0, 0. And then we talked before about how I could graph these. I can do the pattern. And again, the pattern, if I do it that way, is up 1 over 1 each way. And then up 3 and over 1 each way. And then up, if I can do it, 2, 3, 4, I can, 5 and over 1 each way. The 1, 3, 5 pattern. Now, if you don't remember that, if you're like, I didn't remember it the first time you talked about it, and I certainly don't remember it now, that's not a problem. Okay. My option would be, I could type this in the calculator. Okay. I can go to my table, and I look for symmetry. Now again, symmetry is when I see the same numbers above and below in the middle. Well, I don't see that right now. Well, I'm not at my vertex, which is at 0, 0. Now I see symmetry. So if I know where the center is, and I knew this time the vertex was at 0, 0, I can set that up and then just use the calculator to plot my other points. Okay? So, again, we have options. My boundary, my parabola, is going to be solid because it's or equal to. So nothing too fancy so far. But here comes our one new part. How do I figure out where I shade? Okay? Inside or outside the curve. What we're going to do is we're going to test a point. There are some shortcut ways, but they also come with problems. So I'm going to avoid them for the most part. So I'm going to shade inside the curve if the statement is true. And if it's false, I'm going to shade outside the curve. Okay? And let me add one more thing to my test a point. Inside the parabola. And that's what we're to right now. We're going to attempt, once we get our parabola graphed, to test a point to see Do I shade inside or do I shade outside? And you're like, well, what point do I test? Doesn't matter as long as it's inside the parabola, not on it. Okay, so like I couldn't use 0, 0, that's on it, but let's say I try out this point. And that point looks to be 0, 4. Okay, any point inside would work though. So I test 0, 4. Now remember, when I'm looking at a coordinate, the x value is first, the y value is second. So basically all I'm going to do is I'm going to plug in 4 for y. I'm going to plug in 0 for x. And I'm going to simplify it and see if the statement's true. Well, 0 squared is 0. So is 4 less than or equal to 0?
No.
No. Okay, that's false. So since that's false, I'm going to shade outside of the curve. And just a scribble is good. It doesn't have to be like neat like you're coloring a picture or anything. As long as I can tell that you're shading. I gotta have the shading in there though. Okay, so false will be outside, true will be inside. And that's it. Okay, I look at the next one. The only difference is this plus 4. Now that's a shift. What direction am I going for? Up. Okay, if there were parentheses, the number inside would be left, right. But this is going to be up, so up 4. So I started at 0, 0 before. I'm going to start up 4 from there. And again, I can use the calculator at this point, or I can use my pattern, which again is up 1 and over 1 each direction, and then up 3 and over 1 in each direction. I can't fit the 5 this time. But again, the calculator would give me those same 5 points. What type of line am I going to use to connect the dots?
The dot dash.
Okay, a dashed. Because again, it's not or equal to. So I go ahead, I get that drawn in, and then I'm going to test a point inside the parabola. Again, doesn't matter where as long as it's inside. So this time I'm at 0. I didn't move left or right at all. 7. And again, I'm going to plug those values in. Plug in the 7 for y. Okay, 0 squared is going to be 0 plus 4. Is 7 greater than 4? Yes, that's true. True, we shade inside the parabola. So true in, false out. But again, I just got to make sure I graph my parabola accurately. And then, of course, you know me, we got to get a twist in. Okay. What's going to happen unusual with this one? What's the plus 2 going to do? Okay, I'm going to go up 2 to start. But yeah, the negative means, right, my parabola is going to open down instead of up. Pattern would still work, except I'd go down 1 over 1, and then down 3 over 1. And this time I think I got room for my 5. 1, 2, 3. And again, I'd get the same points, and I'll even show you. I'd get the same points if I went to my calculator and just typed it in and looked at the chart. Okay, I still see my symmetry. There's my 0, 2, my vertex. And I'd use those other points to plot. But how am I going to connect them again? What type of line?
Dotted.
Dotted. And now we're a test point away from being done with this one. Now this time I can use 0, 0, so I'm going to go ahead and use that. So again, what's 0 do? It basically wipes out everything. So 0 is less than 0 plus 2. Is 0 less than 2? See? It is. So I stay inside the parabola. Okay. So this way works well when I just have x squared and a plus minus number. Okay? But again, I can just punch it in the calculator. It would get me the same information back. Are they always going to look just that way, though? No. We've seen how many different ways these can look, so we have to have more tools available. So when I go to numbers 4 and 5, okay, the way I'm going to tackle this is going to change a little bit. When I get down here, what I'm typically going to do, because you'll notice now there's an x with my number, so I can't just say this is down 4 or up 3. I'm going to have to use my vertex form. Okay, I'm going to have to find my x value using negative b over 2a. And again here, my a value would be 1, the number in front of x squared. The b value would be negative 4. So as long as I'm careful, I'm only going to have to do one thing mathematically, and then I'm going to let the calculator do it. So let's see here. Opposite of b, opposite of negative 4 is 4, times 2a. 4 divided by 2 is 2. You're like, okay, that told me an x value, so what? Well, I could take that 2 and plug it back in for the x's to figure out why, but I'm not feeling that assertive right now. So what I'm going to do instead is I'm going to type it in the calculator, and I'm going to go to my table, and I'm going to get the x value of 2 in the middle of my chart. Check me out. There's symmetry. And it also tells me that when x equals 2, y equals negative 4. And that's where my vertex would be, or my center. So I get that in there. And now again, well, I've already got the chart up. I might as well use it.
Oh, yeah.
Uh-oh. And again, plot some dots. The more you plot, the more accurate your graph is going to be.
Wait, can I see which type of y you
X squared minus 4x. I plugged in
okay,
that.
I put a 2 in.
Gotcha. Okay, so I get my dots plotted from my chart. What type of line am I going to connect the dots with? Solid, because it's or equal to. Get that guy drawn in. Again, pick any point you want inside the parabola. So I'll pick this guy. I like getting a 0 in somewhere when I can. It just makes life easy. So I'm going to test 2, 0, because I went right 2 to get here. You're like, all right. And then again, I just plug in the values. There's 2 spots to plug my x this time, though, so don't forget you got both of them. So 2 squared is 4. 4 times 2 is 8. And I simplify my expression, because I got to see if it's true or false. Is 0 greater than or equal to negative 4? Yes. I would rather owe somebody nothing than owe them $4. True is inside. And hopefully at this point you're kind of starting to see how this can work. And you're like, okay, yeah, there's some steps, but again, the more practice I get, the easier it'll be, and I won't have to think as much. Now, number 5, I'll admit, is going to be a little bit nasty, but nothing we're not going to be able to handle. I get to number 5. And I'm doing my thing. I'm like, all right, so A is 1, B is 3, okay. I'll do my little x equals equation. This is no big deal. So the opposite of B, the opposite of 3 is negative 3 over 2 times A. And you type that in the calculator and you go, uh-oh. Something must have went wrong. I got a decimal. Nothing went wrong. Negative 3 divided by 2 is negative 1.5. Oh. Well, wait a minute, that's going to cause me another problem. Because when I go and I type this into my calculator now, I'm like x squared plus 3x. Okay, I'll just use my chart. oh, wait a minute, negative 1.5 isn't on my chart. What do I do? Well, I do one of two things. I either plug the negative 1.5 in for x in both of these, just in the regular part of the calculator to get the answer, or here's my other trick. If I hit trace, not second trace, just trace, I can type in any x value I want. I know that x is negative 1.5, so I hit trace and I type in negative 1.5 and hit enter, and I get the y value. Now again, if you don't remember that sometime, and that's possible because I mean there's a lot of stuff you're supposed to remember, I've always got the option, as you can see up here at the top, of just taking the negative 1.5, squaring it, okay, using parentheses, plus 3 times negative 1.5. I got the same answer. Okay, so there's multiple ways for this to work in your favor. You're like, okay, but so negative 1.5, negative 2.25. Okay, that's about here. What am I supposed to do about getting my other points? I mean, I could kind of get an idea from this and get some of my other values. I could do negative 2. You know, I could get those in. And then I could do negative 3, 0. I mean, is that okay to do if it's not like perfectly aligned? It is. Okay. We're going to see another way we could do it with intercepts here in a little bit. But that absolutely is going to give us an accurate enough graph to make this work. So you're like, okay, so don't panic. There's a decimal. That's okay. So now I've got to do my test point. And again, pick anywhere you want to go. Doesn't matter. Well, this looks good. I always like to make sure I'm plenty far away from the parabola so I don't have a boo-boo. So negative 2, positive 2. Again, any point inside would work, though. If you use like 0, 8, that would work. So again, plug in the y where y goes. With parentheses, plug in the x where the x goes. I was so gun-shy about wanting to make sure I stayed in the middle. I probably would have made life easier on myself if I'd used like 0.4 or 0.6 or something like that. I'll get the same answer at the end, though. The statement will still be true or false no matter which route I go with this. So I look and I'm like, is 2 less than or equal to negative 2? Well, no. And false is outside. But yeah, any point inside will get you the same answer. I'll get a false statement no matter what point I pick to make sure that works. Okay. Issues. So again, we've looked at standard form with just a simple up or down shift. We've looked when there's an x there. Okay, I need to take a little peek when I do that. Now, one more thing popping our way here. And we're going to take a look at these on the back a couple of different ways. Okay, so we're going to graph them. We're going to figure out where the function is above or below the x-axis. I'll explain what that means in a minute with the interval notation. When we get to these, there's going to be 2 steps to getting them done. Okay, I'm going to have to do the x equals negative b over 2a. It's not going to be an option at this point. And then second, I need to factor and find my x-intercepts. I'm going to get 3 points on these for my graph, and that's it. And that's okay. But I've got to do these 2 things to make this work well. You're like, well, could I just go to the calculator and hope I get lucky? You could, okay. But a lot of times you're not going to. So I look at this, and I go, okay. Gotta factor this sucker. Now remember, multiply to get the number on the end. So to multiply to get a positive, they're both positive, they're both negative. But add to get the number in the middle, which is negative. So both of these suckers are going to be negative. So I need two numbers, thank you, that multiply to 5 and add up to 6. 1. And again, I'm finding zeros, so I take each of those sets of parentheses, set them equal to 0, and solve them. These are my x-intercepts. So they're going to be the dots right on the x-axis. Okay, there's 2 of my 3 dots. My third dot is going to come from using my little mini formula. So x is going to be the opposite of b. The opposite of -6 is +6 over 2 times a.
What is that? X minus what?
X equals negative
No,
b.
no, down there. X minus 1 over t.
X-intercept?
Oh, X-intercept.
X-intercept. So once I get here, again, I've got options. What I'm probably going to do is, I'd probably do it in my head. But if you weren't going to do it in your head, now you're just going to take this 3, and you're going to go ahead and you're just going to plug it into here. Because again, I need that value. So 3 squared minus 6 times 3 plus 5. So my y value would be -4. Gives me my vertex. 3, -4. Okay, those are the only 3 points I'm getting. I'm not going to be able to get any more. So all I got to do now is say, okay, we're going to be going dotted. And I do my test point. I'm like, that looks pretty safe. So if I test 3, 0. I look at that and I go, okay, let's see here. You're like, Harty, there is no place to plug the y value. That's okay. Then we don't plug a y value. We just plug the x. So we're going to have 3 squared minus 6 times 3 plus 5. And I'm assuming we type that into the calculator. So it'll be 9 minus 18 is -9 plus 5 is -4 less than 0.
Yeah.
See? So since it's true, I shade inside. But this time there's one little part that's left. It wants to know what the interval notation of the solution is. And here's where our combination from what we've graphed before comes into play. When we were graphing before and we were doing interval notation with parabolas, okay, if my x squared value was something that was less than, okay, that was an and statement, and when we shaded, or when we did our interval notation, it was in between like this. When my x squared was greater than, it's when I did the ors. And the ors were the ones that got really big and had negative and positive infinity going and all that other stuff. That's the same thing I'm going to do here. So once I've got that part, once I put that back into my memory bank from when I did this before, I take a peek back at the expression. X squared is less than. This is an and statement, which means I'm going to do the interval notation for this part right here. So I'm going to go left to right. My left is at 1. Okay. Parenthesis, because it's not or equal to. To right, my right point's my other x-intercept, which is 5. Okay. So less thans are going to have very small interval notations. Greater thans are going to have big ones. And we've got to work through that. So I look and I'm like, okay, I kind of see how this is working. There's a lot to keep track of, but again, the more practice you get, if this is your first time going through dealing with this, because we haven't done some of it before, you know, it's going to take a little extra time because you're kind of digging out of a hole with a spoon instead of a shovel, but we can still get you there. So I'm like, okay, one more. I can do this. Oh, even got to slide and divide in this stuff sometimes. Sometimes. So I got the 2 in front. Slide it on down. And then I need to factor that. So I get here and I'm like, okay. Let's see here. Multiply to -6, so I know it's one of each sign. Add to -5, I mean the negative sign's bigger, so -6 and 1, but don't forget the divide part. I did that a lot in the last quiz. I was marking things like, oh, did everything right and forgot the divide. I'll admit it, I forget sometimes. If it doesn't reduce any further, back to the front. If it does, great. And again, those are going to be my x-intercepts. When I solve these, and I got to do both, and yes, decimals are okay. Don't flip out. Those are going to give me 2 of my 3 points that I need. So I get those 2 guys nice and big. And then I do my mini formula and I'm going to be done. So I go, okay. So let's see here. Opposite of B. B is -5, so the opposite would be 5 over 2 times A. 2 times 2, plug that in the calculator, I get a decimal, don't flip out. All I got to do, if I get the decimal, is again, like we saw before, I can either type this in and then hit trace and hit 1.25, or I can just take care of it myself and type it in the calculator, which works with any type of calculator. Okay, so my vertex is at 1.25, -6.125. So you see how, you know, just trying to deal with the chart doesn't work every time, because I can't just approximate it and round it. That doesn't quite work. So I get my 3rd dot. It's solid. I'm looking for my test point. I'm going to find me a safe one. That looks safe. 1, 0. And again, I'm going to plug the 1 in where the x's go. So let's see. 1 squared is 1 times 2 is 2. 5 times 1 is 5. And again, or you can just type it all in the calculator and let it do it. So is -6 greater than or equal to 0? Not the last time I checked. False is a whole lot of shading. But remember, to get my interval notation, basically what I'm doing is, where the shading is where I'm doing the interval notation. So either I remember it's an or because it's greater than or equal to 0, or I just look and say, okay, so on the x-axis, wherever it's shaded, that's where my interval notation is going to be. All of that. So it's one of the big ones. It starts all the way over at the left at -infinity. Comes all the way until this first dot at -1/2. Then it starts up again at my other intercept. Goes forever off to infinity. So you kind of start to see the connections between your graph here and how a graph would work on a number line, because this is really looking more like the number lines we used to do, is what I'm trying to find for my answer. Okay. So speaking of number lines, I want to hit up at least one more here. I'll see if I can hit both, but if I can't, we'll be all right with one. Okay. What if I don't have a grid graph to look at with shading? What if I just have a number line? Can I still do this? Sure. Okay. All I'm going to do if I do this is I'm still going to do the same steps from up above. Okay. I'm going to factor to find the zeros. Then I can either use a test point with the true-false test, or use my little and/or trick from up above. So you're like, okay, now how would these both work? I'm kind of trying to see what you're up to here. Okay. I look at this and I go, yeah, that looks factorable. And it is. Okay, I go ahead and I factor it. I gotta find my zeros. Okay, don't just use the values that are there, because that'll get you backwards. So once I get those solved, once I know what the x values are, I'm going to go ahead, I'm going to plot those on my number line, and I'm going to do one of two things. Either I'm going to look at this and say, ooh, that's an or statement. The or statements go out, and I'm going to go ahead and I'm going to graph it. Okay, that's one way I can do it. If I forget that, here's my backup plan. What's a number between -2 and 4? 0. Good pick. Okay, I'm going to choose a test point that's in between here. So I'm going to test out 0. So if I test x equals 0, I'm going to plug 0 in. 0 squared is 0. 2 times 0 is 0. And I'm going to simplify this. And I get to here and I go, okay, let's see. Is -8 greater than 0? No. Whichever portion you tested, okay? And here with these numbers, I like to call it part A, part B, and part C. I tested part B. Part B was false. I don't shade where part B is. I shade in the other parts. If I'd have gotten a true statement, I'd have shaded in B, and I'd have not shaded in the other two. It's sort of like doing the test point with the parabolas, except I'm doing it on a number line. They both work, okay? If you know your ands and ors, that's the faster way, but they both work for me. And once I get the graph, now I just do the interval notation of it. -infinity to -2. Then it starts up again when I get to 4. It goes off forever. But you can see how it actually works. Either way, okay, with the and/ors or with my test point. So last one I'm going to give you a Cliff Notes version of, okay? When I factor this, I'm going to go ahead and factor it for you instead of running through the whole slide and divide, because I want to make sure we get down to the big part of this. So I get to here, I get it factored. I set each of these equal to 0 and solve them. To get both of my intercepts. Okay, and this time instead of and ors, I'm going to go straight to using a test point. So I'm going to go, okay, got my 3 sections, A, B, and C. I always want to test a point in the B section because Then I only got to test once. Now this one, not quite as much fun. I need a number between -2 and -1/3.
-1.
-1. Good pick. So, I'm going to test x is -1. So when I plug that in, actually, let me do it in the calculator. I want to make sure everybody's feeling comfy. So I got 3 times -1 squared. Where'd I go? There I am. Plus 7 times -1 plus 2. Boom. So is -2 less than or equal to 0? Yes. Which tells me section B is the right section. This section right here is where the answer is at. It's an or equals to, which means I should be using brackets. And that's where my interval notation falls. From left to right. Or I could have looked at this and said, ooh, that's an and statement because my x squared is less than, and ands always come into the middle and are shorter. Doesn't matter, they both work. So, that's what typically seems to be the point in here for some strange reason. There's a worksheet of sheets that go exactly with this. Now, I'm going to make mention of one thing, and then I'll zip my lip here. I put a reminder on here, but there's a caveat to it, so be careful. If it's less than 0, typically you're going to shade inside the parabola. I would still use a test point, okay? Typically, if it's greater than 0, it's going to be outside. But if x squared isn't positive, if it's like a negative, if it opens down, it switches those. That's why I don't like the little tricks. When I saw who put this together, put that on there, I wasn't real happy. But I would use a test point. Test point, test point, test point to make my life easier. Tomorrow we're going to work on this same stuff. There's not going to be notes though. We're just going to do a couple of examples off the worksheet that we're doing. So there's going to be plenty of time to work, but I'm going to say it like I always do. There's 8 problems on here. What I would do, sometime before tomorrow, do one problem on the front, and then one problem on the back even, just to get some practice at this. So you're not just, getting yourself into a bind here with what you're doing, okay? And we will take a look at that then.